Welcome, geometers and seekers of truths. In this lesson, we are going to look at inverse trig ratios. So emphasis here on the word inverse trigonometric ratios. And to give you a very quick colloquial definition, we can say that inverse trig ratios, I should really say inverse trig functions, they take a ratio as an input and gives an angle as the output. Now, what do I mean by that? Well, to really talk about inverse trig, let's compare it to just regular quote-unquote trig ratios. So, for example, if I have in this picture here, if I do something like the tangent of A, right, and you can tell me that the tangent of A in this case would be the opposite leg, that's BC, divided by the adjacent leg, that's AC. Okay. Now, that's the equation. Now let's think about the meaning of this equation. This A right here is an angle. That's our input into the function. And this BC over AC here is a ratio, namely the ratio of the opposite leg and the adjacent leg of angle A. Right? So for an inverse trigonometric ratio, what we would do is we would write the tangent inverse, and this superscript -1, it looks like we're raising this to the negative first power, but that's not what it really means. It's just a weird notation that means the inverse trig ratio. We could say that the inverse tangent of the ratio BC over AC is equal to the measure of angle A. Okay? So you see here that we have inverse operations here, that instead of taking in an angle, this time we're going to take in a ratio, and the output here is going to be instead an angle. Okay? And so this type of operation is very useful when we are trying to figure out the missing angle of a particular triangle. Okay? So let us look at this example here, and then let's work through some of these cases. So if the tangent of A is equal to x, then the tangent inverse of x is equal to the measure of angle A. So if we use this picture here, I've already written up here for you the tangent inverse of BC over AC is equal to the measure of angle A. And we can apply that exact same logic to the sine and the cosine inverse, to the sine and cosine ratio as well. So if the sine of angle A is equal to some number y, then the sine inverse of that number is equal to the measure of angle A. And let us use our picture here. The sine inverse of what is equal to the measure of angle A? This is the equivalent of saying the sine of angle A is equal to what? Okay, so we can see in this picture here, the sine of angle A is equal to the opposite leg, which is BC, over the hypotenuse, which is AB. So that means the sine inverse of BC over AB is equal to the measure of angle A. All right, now let's continue. Same idea with the cosine ratio. If the cosine of angle A is equal to some number z, then the cosine inverse of that number is equal to the measure of angle A. So in order for us to fill in this blank here, well, the cosine inverse of what is equal to the measure of angle A? That's the same thing as asking the cosine of A is equal to what? Well, the cosine of A from our picture here is the adjacent leg, which is AC, divided by the hypotenuse, which is AB. So the cosine of A is equal to AC over AB. That means the cosine inverse of AC over AB is equal to the measure of angle A. All right, so this is kind of weird and new, but all we're really talking about here is reversing the order of an operation. Instead of taking in an angle and producing a ratio, we are taking in a ratio and producing an angle when we perform an inverse operation. All right, I'll end this video here. Let's look at the next video where we apply some more examples, when we apply this concept to a few more examples.